Today, I'm going to demonstrate how the Tetra Data platform can simplify your data management around high throughput screening. High throughput screening is relevant in nearly all of our customers' laboratories that we work with today. Unfortunately, managing high throughput screening data is burdened by manual data collection and transformation. For example, say I'm a scientist over here on the right, and I want to gather some insights from my data. I may use Spotfire, an ELN, or another application to create a heat map of my compounds, generate some IC50 curves, or run some other sort of analysis. But the process to gather that data can be painful with today's data management strategies. You have data coming from many sources, and as the scientist doing the analysis, I may have little or no access to those data sources. And this results in point-to-point integrations to get data from one place to another. So say we're using Prism to get data in, we'll have to write some Python code to get the data formatted properly for Prism, to send the data to Dotmatics. We'll have to do some more manual transformations for proper formatting. We may want to augment our data in Dotmatics with information from Titian, so more point-to-point integrations. And then the same with something like benchling. We'll have to rewrite the integrations to play nicely with benchling. And we also want to look at our cell counter data, right? Maybe we do that through BioVia One Lab, requiring additional data manipulation. And you might not be working with the same systems, but I just want to highlight that there are typically a lot of manual transformations that we need to create. And on top of getting the data into these sort of the ELN or LIMS applications, if I want to analyze the data in Spotfire, for example, I'd likely need some sort of export and utilize some sort of file share to put the data in one place. Then probably have to mess with that data again, right, to get it into a format where I can push it into Spotfire. And it's likely I'll want to use R or Python or another analysis tool to do, build some sort of visualizations or gain some insights to our data. So, with the current processes, the data analysis is possible, but it's just not necessarily efficient. And that process of what should be simple analysis is bogged down by numerous point-to-point integrations and manual transformations that delay time to insight of your data. So one of the reasons we're brought in many cases is to accelerate your time to insight and simplify your data management. And that's where the Tetra Data platform comes in. We're not trying to replace the applications that you're using because those are still bringing you a lot of value, nor are we trying to add another application for you to interface with. Really, the platform's objective is to transform and move data between applications behind the scenes so you don't have to. And with our pre-built collection of connectors, we're able to trigger pipelines to process based on events happening. So when the platform sees data of a certain type, it automatically transforms or moves the data where it needs to be without human interaction. We only need to collect data one time because it'll be stored and archived up on the platform. And then what we can do is we can contextualize the data by injecting metadata that we can search and filter on. We can harmonize the data to a vendor-agnostic format to make the data actionable. If we need, we can verify and enrich the data. And then we're able to publish the data to downstream applications like ELNs or LIMS or Spotfire or R or Python. If I'm using Spotfire, maybe I'm using SQL to pull the data. And if I'm using Python or R, maybe I'm using the API to pull the data from the platform. So a lot of options that you have. And really what we're trying to do is make the data fair. By storing the data in a centralized location on the cloud with search capabilities, the data becomes findable and accessible. When we expose the data to access via API or SQL, the data becomes interoperable. And the data is also reusable because we can use any application we want to connect up to the platform and grab the data. Now we'll go through a demonstration of how this data management will be applied on the Tetra Data platform. And the first thing I'm going to do is ingest some liquid handler data to the platform. And I'm going to go into my Ignite account. Ignite is similar to Box or Google Drive. And I'm simulating a file from a liquid handler being exported into some sort of desired folder or some sort of desired location. And that's what I'm doing by dragging and dropping this file. And since I don't have a liquid handler, I'm going to simply drag and drop a file from a Tecan D300 liquid handler into that desired folder. And this folder I dropped the file into is connected to the Tetra Data platform. That way, as soon as the folder sees a new file come in, it automatically pushes the file up to the platform. And when the file arrives, the platform will automatically harmonize the Tecan file to a vendor-agnostic format to make the data actionable downstream. So let's have a look up on the platform to see what the start of this process looks like. So I just refresh the platform and I can see my Tecan file is here. And I can see the time is 4:10 p.m. when that file was dropped, and it's 4:11 right now. So that is in real time. And if I go to my pipelines that I have built up on the platform and look at my pipeline processing to see what's happening with this Tecan file, I have a harmonization pipeline that takes the raw Tecan file and harmonizes it to our intermediate data schema or IDS to that vendor agnostic format. And it looks like this pipeline completed at 4:11. So that's right now, it looks like that pipeline just completed. So if I go back to my data lake, I can see the raw file, the raw Tecan file, and I can also see this JSON file, which is my intermediate data schema. So that file that's been harmonized to that data, to that vendor agnostic format. So I can see both those files up on my data lake now. So now we have our liquid handler in a harmonized format on the platform. All I had to do was drag and drop that file, but in reality, the liquid handler could export the file directly to the folder connected to the platform for even less human interaction. The next thing I want to do is bring my plate reader data to the platform, and I'm going to do this similarly as how I connected the liquid handler data through Ignite. So I'm going to grab my file of interest here and drag it into the file that is connected up to the platform. So once again, I just drag and drop that file. And here I'm working with Envision plate reader data. The folder I dropped the Envision plate reader data into, it's also connected up to the platform. So as soon as the platform sees this file populate on the platform, a pipeline will be triggered to execute. So let's take a look at how that happens. Back to the platform, just refresh the page. Still waiting for that file to come in, it looks like. Let's just double check to make sure I dropped the file where I wanted. It looks like I did. Refresh the page and I can see at 4:13 p.m. is when that file drops. So it looks like that just dropped now. And from that file dropping on the platform, it will also trigger a pipeline. So in a similar fashion, we'll take a look at that pipeline. Look for my Envision pipeline here. So this pipeline is currently in progress. And as we can see, there are a number of different tasks associated with this pipeline. And we can jump in and see what those tasks consist of. So the first thing that happens when the file drops on the platform, the Envision plate reader data, we have our Envision raw to IDS. So similarly, we're taking that vendor agnostic, that vendor specific format, and harmonizing it to that vendor agnostic intermediate data schema. The next task in this pipeline is extracting experiment info. So we specify experiment info that we're interested in, that we want to use downstream. So we're going to extract that. This pipeline is actually querying the TCAN IDS, which was that liquid handler data that we brought in first. So our liquid handler data came to the platform, so did our plate reader data. And what we're able to do up on the platform is actually query that liquid handler data. And that's what we can see happening within this task. After that, we generate an assay plate template, and then we aggregate the TCAN file and the plate reader file together. And then what this last step is pushing the assay plate to Dotmatics. So in an automated fashion, we can push our data from the platform to an application in ELN like Dotmatics. So I'm going to go back to my platform here, and it looks like I have my IDS that just finished harmonizing to that intermediate data schema. I'm going to take a look back at my pipeline processing and look for the pipeline this file was going through. It looks like it just completed at 4:15 p.m. So with completion of that pipeline, I would now expect the data to be populated up in Dotmatics. So now I'm going to go to my Dotmatics browser here. I'm going to go into my studies. And then I'm going to look at my Screening Ultra IC50 demo here. And I see a new experiment here. And when it was created was the March 6th, which was today. And this says at 18:15, which is 6:15, and that's Eastern time. And I'm on Mountain time, so I am 2 hours behind Eastern time. So that is actually up to date, 4:15 my time and 6:15 Eastern time. So let's dig into this experiment here. And I can look at my results. So I can look at my plates, for example. I can see a heat map of my plates, all populated directly from the Tetra Data platform by creating that assay that we did in our pipeline here. When we pushed our assay plate to Dotmatics, Dotmatics automatically populated with our information from the pipeline. So here I have my heat map. I can look at some plate statistics here. I can drill into my samples a little bit more, look at the layers, see what my raw data result is, or see what my concentrations are. And all of this data is pulled directly from the platform. We have our results, our mins, our max, our slopes associated with our IC50 curves. And then we can see all of our IC50 curves up in Dotmatics as well. So very little human interaction of data transformations, no data transformations that I had to do, or point-to-point integrations, all automated through the platform. If I go back to my slides here, so I was able to push my desired data to Dotmatics, and really by leveraging the Tetra Data platform, we're able to automate data flow from our instruments to a centralized location in the cloud to any downstream application of your choosing. In this case, we use Dotmatics to look at some heat maps and IC50 curves of our compounds. So I hope this was helpful, and thank you for listening.